Hello, ladies and gentlemen, and you're watching Paleo 101, where we talk about fossils, minerals, everything recorded in the Earth's rocks. Today is June 30th, 2018, and today is Asteroid Day. Now, why was Asteroid Day created, and who created the event? Well, Asteroid Day was created by Brian May, who is the lead guitarist of the band Queen, and he's also an astrophysicist. Asteroid Day was created to spread awareness of asteroids and comets entering the Earth's atmosphere. So, before we get started on some of the samples to understand how meteorites form and some of the clues that you can tell, we have to really clear up three things. We have to clear up the three terms. What is an asteroid, what is a meteor, and what is a meteorite. So an asteroid is is the space rock given to the name where it's still in orbit in space. Meteor is when it approaches a planet's atmosphere, and meteorite is when it hits the Earth or hits a known planet. So what are some of the structures that we can see in order to really understand how meteorites hit the Earth, and what structures can we see in rocks to understand that specific event? Well, there is one thing that I have on the table here. These are called shatter cones. Shatter cones are created when a known asteroid hits the Earth and creates these lines and creates these structures in the rocks. Now, they're specific structures. They are actually made by the waves, by the force of impact when an asteroid hits the Earth and creates these lines and creates these jagged edges. So this rock is dolomite, but you can see these jagged structures here. And here's another sample. This comes from Well Creek Basin in Tennessee. So here's another sample. And you can see these lines that go all in all one direction. These lines and these structures were made by the asteroid impact itself. So when the asteroid was hitting the Earth, it created this, and during that was the shock wave, and it created and imploded these rocks. So here's what the shatter cones are. You can see that here is your asteroid impact, and it caved in, and here is the actual shatter cones itself. And shatter cones are very defined by asteroid impact. So if you find these kinds of structures, it will begin to tell you that maybe there was an extraterrestrial impact that occurred some millions or thousands of years ago. This asteroid this impact was formed during the early Jurassic, somewhere approximately 200 million years ago. So right when the dawn of the dinosaurs are starting to evolve, or some of the first dinosaurs during the late Triassic, some of the large dinosaurs like sauropods and maybe a few allosaurs and things of that nature started to really occur in the early Jurassic period and later in the late Jurassic period. But this event occurred during the early Jurassic period, approximately 200 million years ago. And so we actually have these structures called shatter cones to actually know that there was an extraterrestrial impact somewhere in Earth's history. And asteroids have been forming or have been colliding to Earth billions of years ago. We actually have some of the largest asteroid impacts have occurred during the formation of our solar system and the formation of Earth itself. And some of these asteroids impacts are not necessarily seen because Earth is very dynamic. You have volcanic activity, you have erosion, you have oceans starting to form. And so if we actually strip the oceans away, Earth will be covered in asteroid impacts. There is an event called the bombardment effect, in which these asteroids were hitting the Earth billions of years ago. And this was a time in Earth's history, 4.5 billion years ago, where Earth started to be completely bombarded by asteroids, hitting the Earth and creating probably some of the features that we see in these rocks today. So you'll see these features, and they're quite definite, and they're there. You know, you have to really look at them. You have to really understand their structure and how they formed. It may not actually look like it to you, or may look like it to a person of a naked eye. But when you actually look at these and you actually go to different locations, you'll begin to see very similar structures and begin to really form the pieces together and say, okay, this probably was formed by an asteroid impact. But shatter cones are not the only thing. There are also different kinds of structures and different kinds of places where you'll understand that this particular structure was formed by an asteroid. We have these things called tektites, these black looking rocks, and they can also be in different colors. They're actually glass. If you actually hold it up to a light, some of the samples may be able to pass through light. These are actually impact glass. And the structures like shatter cones and tektites are known as impactites. They're formed by asteroid impacts. So yeah, you actually have these things called tektites, and tektites are actually the rocks or some of the sediment that is actually solidified and has actually formed into this natural glass. So you'll actually find this. These are quite common. This particular specimen comes from Thailand, and this is what we call as a tektite. And tektites contain a little bit of a small amounts of water, at least 5% of water, and they formed during the asteroid impact. So you'll see a lot of these, and some of these samples can be microscopic, which means you can see them and you can hold it in your hand. Some of these may be microscopic. You actually have to use a microscope in order to see specific tektites. So many of these were formed by an asteroid impact itself. Now, we all know the asteroid impact that killed off the dinosaurs 66 million years ago. Now, what exactly is the evidence for that? The KBG boundary. The KBG boundary is the term given to the Cretaceous and Paleogene, which was the ending of the Cretaceous period 66 million years ago and the beginning of the Paleogene period. And so we actually have this. Now, this may not look like much, it's just in a little bottle, but this is actually sediment from the KBG boundary from places like South Dakota and Colorado. This particular specimen comes, this particular sample comes from Colorado, and it's from here. This is the KBG boundary. This is in Trinidad, Colorado, and here you can see the rock here. This is the Paleogene, and here you can actually see right in the middle. This is the KBG boundary. So below that are the Cretaceous sediments, where you'll find dinosaurs like Triceratops and Tyrannosaurus Rex, and others. Above that is the Paleogene boundary, and right in the middle is the KBG boundary. Now, what evidence is there to actually show that there was an asteroid impact 66 million years ago? Well, the sediment that occurred was laid down around the world. So the first occurrences of the KBG boundary itself occurred in places like Italy. But what actually is there evidence is there to understand and to know that there was an asteroid impact 66 million years ago? Well, inside the sediment, we actually find microtektites. So I actually put this sample of the KBG boundary under a microscope maybe about 3 years ago, and I looked under it, and you can see these glass beads. These are microtektites. So as the asteroid was coming in and hitting the Earth, it impacted and shattered all kinds of things, and making the microtektites that I actually saw in the microscope. So they were quite small. They were spherical in shape, and so actually, when the sediment was being hit by that meteorite, it completely vaporized it and turned it into this natural glass. So we actually see that in a lot of asteroid impacts around the world today. You'll find macrotektites, you'll find shatter cones and things of that nature. But you'll also find a high deposition of iridium. And iridium is a rare earth element. I believe it's the second lightest element. So it doesn't occur a lot in the Earth's rocks, but it does occur a lot in asteroids and comets today. So this was this is one of the leading, or what we call the smoking gun, to show that there was an asteroid impact, because we had this high percentage of iridium. And so we actually have it in some of the KBG boundary. We actually have a lot of it indeed. There is more iridium in the KBG boundary alone than there was in any other Earth rocks today. So this is one of the evidence to show that there was an asteroid impact 66 million years ago. Not only do we find the high occurrences of iridium, but we actually find this. This is shocked quartz. Now, quartz, as we know, is a very common mineral. It's one of the common minerals in the Earth's rocks today. But shocked quartz is not necessarily known in specific areas and specific forms. Shocked quartz is only formed by explosions. It's only formed by the high vaporization of this mineral, and it's destroying the crystal lattice. So shocked quartz is also a leading example, is a great example to understand that there was an explosion, possibly an asteroid impact that occurred somewhere in Earth's history. So asteroids are common. I mean, they pass through out of Earth in the Earth's atmosphere pretty much all the time. They've been doing this for about billions of years. So we are basically in a shooting gallery of asteroids and comets and meteorites that are hitting the Earth on a daily basis. Well, not on a daily basis, but some of them occur very commonly. And so about 3 years ago, the Chelyabinsk meteorite impact that occurred over Russia was just 3 years ago. It occurred, I believe, on February 14th, and on Valentine's Day. So this was an asteroid that hit the Earth and it did a lot of collateral damage and millions of dollars, and it also unfortunately killed people and injured people. So this was a meteor that really was a destructive force. Now imagine the asteroid impact that killed off the non-avian dinosaurs 66 million years ago. That was about the size of Mount Everest, and it would have done huge, huge collateral damage. We actually have, again, we actually have the deposition of the KBG sediments all around the world to show that this was a catastrophic event. This was an event that occurred all over the globe, and it probably would have basically would have made a nuclear winter, and animals would have died right then. Now we actually have dinosaurs today that are right close to the asteroid impact. Now we don't have dinosaurs above the asteroid impact, but we do have dinosaurs below it, and we actually have those clues. We actually have the deposition of this sediment here. We have iridium spikes, and we have microtektites. We have shocked quartz, and so all of these various evidences show that there was an asteroid impact somewhere in Earth's history, and the 66 million year old asteroid impact was not even the largest asteroid impact to that have occurred in Earth's history. There has been clues to show that this asteroid impact was probably just maybe one of the largest, but it wasn't the biggest that has occurred in Earth's history. Somewhere between as the Earth was forming 4.5 billion years ago, that's where you actually started to have the largest asteroid impacts that we have known today. And so the 65 million year old asteroid that we see, or the asteroid impact that we see today and that we all know, was not the largest in Earth's history. It was it was a big one, but it wasn't the largest. So the asteroid impact 66 million years ago is very famously known because of the evidence that we have. It would have been a crazy idea to actually propose that there was an asteroid impact 66 million years ago, but the evidence leads to that. You always have to follow where the evidence leads you, and if you find things, specific clues and minerals that don't necessarily form under high conditions during the Earth's history, or specifically I should say during natural occurrences on Earth, they actually form as an asteroid impact or large explosions. You actually see these particular minerals inside of that. You'll see high occurrences of iridium, you'll see shatter cones, you'll see microtektites. So things that don't occur naturally on a daily basis in the rock cycle, you'll begin to see that maybe there was something else that actually occurred billions or millions of years, or even thousands of years. The largest meteorite impact that I know of that I've seen is the Arizona crater. This crater was formed 50,000 years ago, and this was a huge crater. I mean, if you stand on the rim of the crater, it's gigantic. So this is just a large feature. This is a hole in the Earth from an asteroid that was huge. Probably maybe not as large as the asteroid impact that killed off the non-avian dinosaurs, but it was quite large. And so you'll see shatter cones. You'll see brecciated rocks that occur. You'll see microtektites. You even have fine occurrences of iron inside of that asteroid impact. And so that impact was gigantic, and it formed a gigantic hole in the Earth. And so meteorites are very dangerous. Okay, we live in a shooting gallery of asteroid and meteorite impacts. And so if we don't get rid of ourselves during the sixth extinction, maybe an asteroid will kill us off and go. So asteroids are very dangerous, and they occur in many places. So I inform you to watch out for these things as they occur, because who knows? Maybe will we be next of an asteroid that may kill us off? Or do we actually have newer technology to deflect a meteorite in order for us not to, or in order for that object to not to hit us? So maybe we actually have the technology to deflect asteroid impacts, or maybe we just have to wait to see in the near future as technology advances. This is Paleo 101. Happy Asteroid Day, and I will see you later with another video.